Assalamualaikum and hello everyone. Welcome to our presentation for MAT210 discrete maths. My name is Sumisha Ajuna and today our group is going to guide you through a fundamental topic in discrete maths, which is logical connectives. So what is logical connective and why do we use it? A logical connective is just a math symbol used to join single sentences into one combined statement. And the main goal here is very simple. These symbols give us fixed rules so we can find out if a combined statement is completely true or completely false without any guessing.
My name is Nurul Izzati and here is the types of logical connective. We have 5 types of statement. First, we have conjunction and the logical connective is AND. For second one, we have disjunction. The logical connective is OR. And then third, we have type of statement negation, which the logical connective is NOT. And the fourth one is implication. The logical connective is if then. And lastly, we have biconditional, and the logical connective is if and only if. Next, I will explain the conjunction, also known as AND. It combines two statements into one compound statement. And a conjunction is true only when both of the statements are true. Otherwise, it will be false. For example, let P represent I finish my work and Q represent I watch K-drama. The conjunction P and Q is read as I finish my work and I watch K-drama. This statement is true only if I finish my work and I also watch K-drama. If one or both of the statements are false, then the conjunction will be false. So, it's shown in the truth table where P is true and Q is true. The result will be true since P and Q is true only when both P and Q are true. And then for the second row, we can see that P is true and Q is false. The result will be false since there is one fault, so the result will be false. Same goes to row 4 and 5. There will be false for both row and the result will be false. So, in conclusion, the AND connective requires both statements to be true for the whole statement to be true.
Hi everyone, I'm Zafira and today I'll be explaining the second logical connector, which is dysfunction, also known as OR. It is represented by the symbol V. A disjunction is translated as OR and it is true as long as at least one of the statements is true. For example, let P represent I finish my work and Q represent I watch K-drama. So P by Q means I finish my work or I watch K-drama. Now, let's look at the truth table. If both P and Q are true, then the statement is true. If P is true but Q is false, the statement is still true. Likewise, if P is false but Q is true, the statement also remains true. The statements become false only when both P and Q are false. So, we can conclude that the OR connector requires at least one true statement for the entire statement to be true.
Hi, my name is Sharifa Aisha. Now I will explain the third logical connective, which is NOT. The NOT connective is used to change the true value of a statement into its opposite. In other words, if the original statement is true, the NOT statement becomes false. If the original statement is false, the statement becomes true. For example, let P represent I finish my work, while then not P means I do not finish my work. Looking at the truth table, when P is true, not P is false. And when P is false, the not P is true. So the connective simply reverses the true value of a statement. It is commonly used in the mathematics and logical reasoning. Thank you.
My name is Zanuna Shimbeti Zaidi. So for next is I will explain the fourth logical connective, which is if then, represented by the symbol arrow. So it is also known as implication. This logical connective shows a condition and its result. For example, let P represent I finish my work and Q represent I watch K-drama. So therefore, P implies Q means if I finish my work, then I watch K-drama. So looking at the truth table, the implication is false only when P is true and Q is false. So this means the condition happens but the expected result does not happen. So in all other cases, the implication is considered true. So that's all for the if-then logical connective. Thank you.
Next, I will explain the biconditional, also known as if and only if. The biconditional is represented by the symbol if and only if. It combines two statements and is true only when both statements have the same true value. This means both statements must be true or both must be false. For example, let P represent I finish my work and Q represent I watch K-drama. For the statement P, if and only if Q is read as I finish my work if and only if I watch K-drama. Looking at the truth table, when both N, P, Q are true, the result is true. When both are false, the result is also true because they have the same true value. However, if one statement is true and the other is false, the result is false. In conclusion, a biconditional is true only when both statements have the same true value.
Now, let's talk about application in logical connectives. First, in computer programming, developers use them constantly to set up conditions and help software make decisions. Second, they are crucial in digital circuits. The microchips inside our phones and computer relies on physical logic gates like AND gate, OR gates, and NOT gates to process data. And finally, in mathematics, they give us the exact structure we need to solve complex word problems and write solid proofs. To wrap up, logic and basic connective gives us a structured way to analyze statements and decide whether they are true or false. By expressing ideas using symbols instead of everyday language, it becomes much easier to avoid confusion and understand the meaning clearly. Overall, these concepts are very useful, not just in academics but also in real life, especially in computing, where they help us think logically, help make better decisions, and solve problems easier. Now that's all from me. Thank you for listening. Bye bye.